This video covers Lesson 1-5 for Secondary 1 Math, solving multi-step linear equations. So let's remind ourselves, when we solve an equation, we're really asking what number can I substitute it in for the variable and have both sides equal each other. So when we solve, we usually end up with something like x equals 2 or x equals 1/6. And that's the number we can substitute in for the variable x to make the equation true or equal on both sides, or equal each other. So if when solving an equation we get a true statement, so something like 2 equals 2, this is a true statement. Okay, if we get something like this, then our solution is all real numbers. This means that any real number can be substituted back in for the variable and will make both sides of the equation true. Okay, now here's a little side note here, okay, starting there with the S. Since there are infinite number of real numbers, there are an infinite number of numbers that will work. But when we're solving an equation, we want to know which numbers will work. That's the key. Which ones will work? What numbers can I substitute in for the variables and still have each side of the equation equal to each other? Not how many, but which ones. And when we really talk about which ones, we're saying all real numbers. So we want to emphasize that we're talking about all real numbers. When we write our answers, we're talking about which numbers work. Well, all of them will work. There's no numbers that are not going to work out of the real numbers. So how do we write this using set notation? So we're looking at number 2. When we write set notation, remember we have our braces. And inside, when we do all real numbers, we have that fancy R. It's this fancy R. Okay, so if it's a no solution, what am I going to have in my braces? Well, nothing, because there's nothing that works as a solution to this. So this is how we write no solution in set notation and all real numbers in set notation. So let's take a look at an example. And here we're going to justify. So quick reminder, our justifications, we have the addition property of equality, subtraction property of equality, we have the multiplication property of equality, and division property of equality. We also have substitution, which I'll abbreviate, and we have the distributive property, which I'll also abbreviate. So looking at number 3, we can see that we have to distribute this -3 into the parentheses. So we're going to get -9m's, and -3 times -4 is +12, equals -15m's. And we just used the distributive property. Next, notice we've got to get the variables to the same side. And so I'm going to go ahead and add 9m's to both sides of our equation. Now you could do it the other way, but this allows 12 to be by itself and all the m's to be on the other side. So we're going to get 12 is equal to -6m's. And we just used the addition property of equality. Next, we want to get m by itself, so we're going to do the opposite of -6 times m and divide by -6. So that would be using the division property of equality, which results in -2 equals m. This means -2 is the only number we can substitute in for m to make this equation true. Now to place this in set notation, we do brace, and we say m such that m equals -2. Okay, so number 4, we have -6 plus 3d's equals d plus 2d's. You might already see that d plus 2d's, those are like terms. So we're going to use the substitution property and write, instead of d plus 2d's, 3d. So we get -6 plus 3d's is equal to 3d's. Next, let's go ahead and get the variables to the same side of the equation. So I'm going to subtract 3d's. And the reason we can do this is because of the subtraction property of equality, which gives us -6 is equal to 0. Well, -6 is never equal to 0. This is a false statement, so that's our next justification. This is false. So we can say that there is no solution to this equation. There is no value that we can substitute in for d to make this equation equal. And so writing that in set notation, though, we're going to have empty braces. Okay, so number 5. Let's go ahead and take a look. We've got each side. The right side is simplified. The left side is not. We're going to use distributive property since we have that 3 next to the parentheses. So we'll use distributive property, which will give us 3 plus 3w's equals 2w's minus 5. Next, let's go ahead and get the variables the same side. So I'm going to subtract 2w's from both sides of our equation, which gives us 3 plus w equals -5. And we use the subtraction property of equality to do that. Okay, so now we want to subtract 3, because that's the opposite of adding 3 to w. And so we're going to subtract 3. And again, we're using the subtraction property of equality. And this gives us w is equal to -8. Alright, so now we just need to put that in set notation. So the set w such that w equals -8. Okay, number 6. So here, again, we see numbers next to parentheses. This means we're going to be using the distributive property. So let's start there. So distributive property. So a third of -6x's. So another way of thinking about this, -6 divided by 3 is -2. So we're going to have -2x's. And then we have 18 divided by 3. Well, that's 6. So we're going to have +6 equals, and distribute the -2 at the same time. So -2 times x is -2x's. And -2 times -3 is a positive. 2 times 3 is 6. Okay, so let's get our variables to the same side. So I'm going to go ahead and add 2 x's to both sides of our equation, which means I'm using the addition property of equality. And that results in giving us 6 equals 6. Well, 6 is equal to 6. Those are the same, which means this is a true statement. And our solution is all real numbers. So we write that with the brace, the fancy R, and then the closing brace. All real numbers. Now you might be thinking to yourself, wait, I would have done that differently. Well, it's true. We could do this differently. If we had the -2x plus 6 equals -2x plus 6, you might have said to yourself, oh wait, those are the same thing on both sides of the equation, so they must also be equal. And you're right, these are always equal. So we could have stopped there. The other thing you may have thought about doing is from that point, and I'll put it here in this yellow, you could have said, oh, you know what, I'm going to subtract 6 instead on both sides of my equation. And that would have given you negative 2x is equal to negative 2x, which is also always true. And that still would have said to us, hey, it's all real numbers, because this is always true. And that's great. So either way is fine. Just make sure you're writing down the appropriate justification. Okay, so number 7 and 8, they're both worked out for you on your paper. And I want you to take a minute and walk through and make sure you understand why each property is doing what, and write down any questions that you have. You'll be able to bring those to your teacher to get any clarification that may aid you in understanding solving equations and the appropriate justification for doing it. So go ahead and pause the video and look at 7 and 8. Okay, so hopefully you've had a chance to look at those and write down any questions you had. Number 9, line A and line B are parallel and cut by a transversal line C. You may write your answers as a decimal, so that's nice. If the measure of angle 3 equals 4x plus 3, so let's go ahead and write that in here. We got 4x plus 3. And the measure of angle 2 is 3x plus 33. I like writing it in to see where they are. And we want to find x. Well, first we got to understand the relationship between 2 and 3. Angle 2 and angle 3 are vertical angles, which means that their measurements are equal. So we're going to set these two equal. So we have 3x plus 33 equals 4x's plus 3. And let's go ahead and get the variables to the same side. So we'll subtract 3x's from both sides of our equation, which gives us 33 is equal to x plus 3. Now if we subtract 3 from x, so adding 3, subtracting 3, we get 30 is equal to x, or x equals 30. Writing this in set notation, we write it as the set x such that x equals 30. Okay, number 10, so using x from number 9, remember that value of x was 30. We're going to find the measure of angle 3 and the measure of angle 2. Now, the measure of angle 3 is 4x plus 3, right, in degrees. And the measure of angle 2 is 3x plus 33. And that's in degrees as well. So to find this, we're going to substitute 30 in for x in each of these equations. If we substitute 30 in for x for the measure of angle 3, that means we will get 4 times 30 plus 3. And 4 times 30 is 120 plus 3 gives us 123. Now, I left off the parentheses with the degrees, but I have to put degrees on this because we're talking about the measurement of the angle. So the measurement of angle 3 is 123 degrees. Now, substituting that 30 in for x for the measure of angle 2, we get 3 times 30 plus 33. And so we get 90 plus 33, which is 123 degrees. Which is good because they should be the exact same measurement since we said that they were vertical angles and equal to each other. Okay, number 11. So if the measure of angle 5 is 3x plus 11 degrees and the measure of angle 6 is 7x minus 1 degrees, find x. Write our answer in set notation. Now, it may be helpful for us to look at this and the relationship of angle 5 and angle 6. So let's take a look at how those two angles are related. So here you see we have our lines A and B and the transversal C. 5 and 6 are the ones we're looking at. So here's 5, here's 6, and they're on the same line next to each other. They're adjacent, but these are our supplementary angles. And supplementary angles means that their sum, so if we add the measure of angle 5 plus the measure of angle 6, we get 180 degrees. And so we're going to use that fact as we write an equation to solve for x. So we're going to go ahead and substitute into this equation our expressions for the measure of angle 5 and the measure of angle 6. So we're going to do 3x plus 11 plus 7x minus 1 equals 180. And to solve this equation, we got to first combine our like terms. So we have some like terms here, 3x's and 7x's. So if we combine these two like terms, we get 10x's. And then if we combine 11 minus 1, those are like terms, we get 10. And so we have 10x's plus 10. And we can continue here, equals 180. And now we are going to do the opposite of what's happening to x. So let's go ahead and subtract 10 from both sides of our equation, which leaves us with 170 equals 10x's. And now we're going to divide, because 10x's is 10 times x, so we're going to divide by 10, and we get that x is equal to 17. Now remember, we need to put this into set notation, so we're going to write that, the set x such that x equals 17. Number 12, using x from number 11, find the measure of angle 5 and the measure of angle 6. So there are three things we need to know. First, we need to know that x is equal to 17. Second, the measure of angle 5 is equal to 3x plus 11. And third, the measure of angle 6 is 7x's minus 1. So what we're going to do is we're going to substitute in 17 for x and find the measurement of angle 5 and angle 6. So we have 3 times 17 plus 11 for the measurement of angle 5. 3 times 17 gives us 51. And we're going to add 11 to that, so we get 62. So we're saying that the measure of angle 5 is 62 degrees. Now let's check and see if this works with the measure of angle 6 as well. So we would have 7 times 17 minus 1. Well, 7 times 17, or 7 times 10 is 70. 7 times 7 is 49. So we're going to get 119 minus 1, which gives us 118 degrees. So the measure of angle 6 is 118 degrees. Number 13. Find the value of x so that the polygons have the same perimeter. Write answers in set notation. Hint: perimeter is the sum of all the sides. So we're going to write out an expression to represent the perimeter of our pentagon. Notice on the pentagon here, all sides are the same. And there are 5, so we can write this as 5 times x plus 3, the length of a side. Now, we're writing an equation first so that we can solve for x. Now we're going to set this equal to the perimeter of our second figure, the trapezoid. And it looks like we have two sides that are the same. So we can write that as 2 times that side, which is x plus 5. And now we're going to add the top, the length of the top of our trapezoid, so 2x minus 3. And we're going to add the length of the bottom, 2x plus 5. Next, once we have this equation, we're going to look for like terms and distributive property so that we can simplify. So I'm going to draw a line down here from our equal sign. Looks like I need to distribute the 5 on the left side of our equation. So 5 times x is 5x's, and 5 times 3 is 15. On the right side of our equation, we have 2 that needs to be distributed to x plus 5. So we're going to get 2x's plus 10, and then we still have plus 2x minus 3 plus 2x plus 5. And now we're going to look for like terms. On the left, there are no like terms. On the right side of our equation, we have 2x's plus 2x's plus 2x's. So we're going to get 6x's. We also have 10 minus 3 plus 5, which will give us 12. So our equation now is 5x's plus 15 is equal to 6x's plus 12. Now let's get our x's to the same side of the equation. So we'll subtract 5x's from both sides of the equation, which results in the equation 15 equals x plus 12. And last we'll subtract 12 so that x is by itself, and we solve for it. And we get 3 is equal to x. So we could check our answer 3 equals x by substituting 3 in where x is in our original equation. Number 14, what is the perimeter of each shape? So let's start out here with the pentagon. So we're going to look for the perimeter of the pentagon. The perimeter of the pentagon is represented by the expression 5 times x plus 3. So we're going to substitute in 3 for x, so we get 5 times 3 plus 3, or 5 times 6, which is 30. So the perimeter of the pentagon is 30 units. Now to find the perimeter of our trapezoid, we do the same thing. We're going to substitute in. So the trapezoid now, so perimeter would be equal to the expression 2 times x plus 5 plus 2x minus 3 plus 2x plus 5. Now we could write it as the simplified form. We knew when we multiplied all this out it gave us 6x plus 12. And so the perimeter of the trapezoid would be 6 times 3 plus 12. Or 6 times 3, which is 18, plus 12. So the perimeter is 30 units. Now here we didn't actually have to use the expression to represent the perimeter of the trapezoid and find it, because we'd already done it by doing the pentagon, and in 13 we set them equal, which means their perimeters would be the same. So this was just a check by finding the perimeter of the trapezoid. This concludes the video for Lesson 1-5, Secondary 1 Math, solving multi-step linear equations.